Assalamualaikum warahmatullahi wabarakatuh, Doctor, and a very good day. So today our group would like to present our project, which is the effectiveness of online and offline learning on student performance. So my name is Ahmad Faris and Muhammad Hafiz, and these are my group mates. Introduction to our project. So this project investigates the effectiveness of online and offline learning on students' academic performance using the dataset that we obtained from Kaggle, which have 1,000 lines of student records. The dataset includes several key variables that enables us to evaluate the relationship between learning mode and academic performance. We use R programming to analyze the data and utilize several statistical methods to interpret the data. The final objective of the study is to determine whether learning mode significantly influences students' academic performance and to identify the factors that are most strongly associated with exam scores. So as I said before, the dataset information have 1,000 students record, and the data that we obtain is a clean data set and there are no missing values. So we didn't have to do any post-processing and cleaning of the dataset. These are the variables that exist in the dataset: learning mode, subject, study hours, focus level, retention score, and exam score. The study hours is in meaning the amount of hours per day. Focus level and retention score is a user inputted value from a range of 0 to 100. And the exam score is the student's final exam score and that's its certain subject. The methodology that we use is first, after ordering the dataset from Kaggle, we imported it to our programming. Then we use these statistical methods, which are hypothesis testing, correlation analysis, regression analysis, and chi-square test of independence to analyze the data. After analyzing the data through our programming, we create an interpretation to determine the impact of learning mood and factors associated with exam performance. So the first testing that we did is the two-sample hypothesis test. The objective of this test is to compare the mean exam scores of online learning students and offline learning students. The null hypothesis is mean online equals to mean offline, meaning there is no significant difference in mean of exam score. And the alternative hypothesis is mean online are equal to mean offline, which implies that there's a significant difference exists between the two learning modes. So after inputting the data into our programming, it calculated a value of negative 3.579. And the critical value at 5% significance is plus minus 1.962. Because our alternative hypothesis is not equal, meaning this is a two-tailed test, and we need to find either the t-value is less than negative 1.962 or more than 1.962. And since our value is negative 3.579 and then it is indeed less than negative 1.962, and the null hypothesis is rejected. So we can conclude there is sufficient statistical evidence that online and offline students have different averages of exam scores. And offline students achieve approximately 2.9 marks higher than online students.
Hi, my name is Siti Fatima, and I'll be presenting about the correlation analysis. So, the main objective here is to determine whether there's a statistically significant linear relationship between two key variables, which is a student retention score and their exam score. To do this, we need R to run our analysis, and as you can see from the code snippet, we imported our dataset and then plotted a scatter plot to visually inspect the data layout. And then we utilize a standard Pearson correlation test to evaluate the direction of the relationship. Next is the result of our correlation analysis. We set our alpha significance level at 0.05, meaning we could reject the null hypothesis if our p-value below than that. Looking at our output, our p-value is incredibly small. It is less than 2.2 times 10, which is below 0.05. Therefore, we confidently reject the null hypothesis. Our percent correlation confidence is 0.798. This indicates a strong positive linear relationship. You can see this clearly in the scatter plot on the right as the retention score on the x-axis increases. The exam score on the y-axis shows a upward trend. So, in short, in short, it means that students with higher retention scores tend to obtain a higher exam score.
Hello everyone, now I'll be presenting the regression analysis session of our project. The purpose of this regression analysis is to determine whether the retention score can be used to predict students' exam score. In this analysis, retention score is independent variable, also known as the predictor, while exam score is a dependent variable, which is the outcome we want to predict. So we used simple linear regression because both variables are numerical and we want to measure how changes in retention score affects exam score. So before interpreting the results, our decision rule is based on 5% significance level or alpha is equals 0.05. If the p-value is less than 0.05, we'll reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. The null hypothesis states that the retention score has no significant effect on exam score, while the alternative hypothesis states that retention score can significantly predict exam score. So, in the results, now let's look at our findings. Here, our regression equation is obtained as exam score equals 29.11 plus 0.586 into retention score. This equation tells us for every 1 point increase in retention score, the predict exam score increases by approximately 0.56 marks. This intercept is uh, this intercept is 29.11, which represents the predicted exam score when the retention score is 0. And although a retention score of 0 is not realistic in practice, the intercept is necessary to define the regression line mathematically. More importantly, the p-value is less than 2 into 10 to the power minus 16, which is far smaller than our significance level of 0.05. Therefore, we reject the null hypothesis and conclude that retention score is a statistically significant predictor of exam score. Another important statistic is the R squared value, which is the 0.6372. This means that approximately 63.7% of the variations in students' exam score can be explained by their retention scores, while remaining 36.3% is influenced by the other factors that were not included in this regression model, such as study hours, focus level, learning mode, or individual learning ability. If we look at the regression graph, we can clearly see, and here, we can clearly see a line positive linear relationship between retention score and exam score. Here we can see upward sloping regression line. Although the data points are scattered around the line, most of them follow the same upward trend, showing that the students with high retention scores generally achieve high exam scores. The relatively small spread of the points around the line also supports that our regression model provides a reasonably good fit to the data. However, it is important to note that regression analysis identify association rather than causation. Although retention score is a strong predictor, we cannot conclude that increasing retention score alone will directly cause the high exam scores because other factors may also influence the student's performance. Thank you.
Hi, I'm Dominic. Now I would like to present chi-square test of independence. So the objective of this test is to determine whether learning mode is independent of students' performance group. The nine hypotheses should be the learning mode and performance group are independent. The alternative hypothesis should be learning mode and performance group are not independent. So the two variables used are learning mode and performance groups. Both are categorical variables. The learning mode consists of online and offline learning. Performance groups was created based on the median exam score of 72. Students who score 72 or above were classified as high performance, while those who score below than 72 are classified as low performance. So the significant level used in this test is 5%. For the decision rule, if the chi-square test statistic is greater than the critical value, the null hypothesis should be rejected. So based on this test, the test statistic is 7.058 and the critical value with 1 degree of freedom is 3.841. Therefore, since 7.058 is greater than 3.841, null hypothesis is rejected. Therefore, learning mode and performance groups are significantly associated in this simulated dataset. The offline group has a higher proportion of high-performing students at 55% compared to 46.6% for the online group. However, this association does not prove that offline learning directly causes better academic performance. Now we go to the conclusion. So to conclude, this study examined that the relationship between learning mode and student academic performance using several statistical methods. First, the two sample t-tests show a statistically significant difference between the average examination scores of online and offline students. Students in the offline group achieve a higher average score. Similarly, the calculated test found a significant relationship between learning mode and performance groups. A larger proportion of offline students were classified in the high performance groups. Therefore, both tests suggest that offline learning was associated with better academic performance in this dataset. The correlation analysis also show a strong positive relationship between retention score and exam score, with a correlation coefficient of 0.798. This means that the student with a higher retention score generally achieve higher examination scores. The regression analysis further showed that retention score explains approximately 63.7% of the variation in exam score, making it a strong predictor of academic performance. However, this finding only showed that statistical association and do not prove causation. Other factors such as motivation, study habits, uh, concentration, and learning support may also affect the student performance. Future studies should include more variables and a more diverse population to provide a more complete understanding of student achievement. That's all for our presentation. Thank you.